In this video, we will go over example 1 and 2 on section 1.3, average rates of change. This is for my math 261 applied calculus 1 group. The learning outcomes for this lesson is to compute an average rate of change, which is slope of a linear function, and find a simplified difference quotient. In section 1.4, we will use that difference quotient. We will also combine it with the limit to define the derivative for the first time. But we have to review this difference quotient that you learned back in Math 161. Got some fun looking functions down here, but in this video, I'm just going to go over example 1 and 2, some basic rate of change examples. A rate or rate of change is a ratio of two quantities. When we're finding the slope using the slope formula, remember we're doing something like y2 minus y1 over x2 minus x1. So I think we will use that down in example 2. But let me read example 1. These look like just word problems. Example 1, state the average rate of change for each situation. Be sure to include units. All right, first one, Jen rode bicycle 30 miles in 3 hours. So what's her average speed? We can say that she bicycled 30 miles over 3 hours. If we reduce this fraction or just do the division, 30 divided by 3, we will get 10 miles per hour. So Jen averaged 10 miles per, but you know what? If I write just M, it looks like meters, so I should probably write as MI, right? 10 miles per hour during the bicycle ride. All right, that one wasn't bad. Second one, it snowed 12 inches between midnight and 8 a.m. So it snowed an average of 12 inches divided by how many hours? 8 hours. So 12 divided by 8 is that what? 1.5 inches per hour between midnight and 8 a.m. All right, last one. Sue earned $250 from selling 8 pieces of jewelry. So I'm going to do 250 and I will divide that by 8 pieces. How do I abbreviate pieces? I'll write it. Pieces. Okay. I may need a calculator for this division. Let me open up a calculator on my computer. 250 divided by 8. Guys, I'm doing this as I'm completing this note. So if I make any arithmetic mistakes or any mistakes, please let me know so that I can address them. So here's my answer. $31.25 per piece from selling the jewelry. Okay, so number 1, why did I add these examples to your notes? I think I saw them on my lab homework, so why not? Just want to go over some similar problems for you. All right, let's look at example 2. Business, revenue, and rate of change. The graph below shows fourth quarter revenue for Groupon from 2012 to 2017, rounded to the nearest $1 million. Okay, so I can see it's going up and then went down a little bit. First question is asking, what was the average rate of change in the fourth quarter revenue between 2013, where is that going to be? 2013, and the number is $768 million, to what point? 2016, which is right here, and the number is 905. So they're asking for the average rate of change. What they are asking for is, imagine drawing a straight line between these 2 points. They're asking for the slope of that straight line. So let's find the slope, okay? Let me write down the order pairs, okay? The order pairs are 2013, $768 million. And the second order pair is 2016, and the corresponding y value was 905. Okay, let's find the average rate of change. Average rate of change equals, I need to subtract the y values. 905 minus 768. And I need to divide that by the x values of 2016 minus 2013. Okay, so what is the numerator? I'm typing this 905 minus 768. Numerator is 137 and the denominator is 3. So it went up $137 million in 3-year period. So if I divide the numerator by 3, this is what I got. It's a repeating decimal. I got approximately $45.6 million. That will be my answer. They did not really say anything about rounding, so I'll just go ahead and say 45.6 repeating million dollars. Okay, but that's how you find the average rate of change, and that is just really the slope formula. Okay, average rate of change in fourth quarter revenue between, now what are they asking this time? 2015, which is right here, and the number that I need to use is 917, and 2017. The y value is 873. If I draw a straight line from this point to that point, the line will go down from left to right because 917 decreased to 873. So we're expecting to get a negative average rate of change. All right, let's find it. I like to write them in an order pair format first. 2015 had a y value of $917 million. 2017 had the revenue of $873 million. All right, time to find the average rate of change. I just want to call it M, you know what I mean? Equals. All right, subtract the y values. 873 minus 917 divided by, subtract the y values. 2017 minus 2015. We're looking at 2-year difference. So denominator is 2. Let me use my calculator for the numerator. 873 minus 917. What did you get? I get negative 44. If I divide negative 44 by 2, I will get negative 22, and we're talking about $million. And as we expected from the numbers and from the chart or the graph, the average rate of change is negative because the fourth quarter revenue decreased from 2015 to 2017. So we looked at 2 examples, a couple basic word problems involving average rate of change. I will be back in my other video to go over example 3 and start difference quotient.